Hello students, integration by partial fraction is what we are going to discuss in this module also. Let's take the very first example in this module. It says evaluate the integral 1 upon x into log of x into 2 plus log x dx. Correct? Let's start the solution. Now my dear students, let me copy the question, but before I go to comment further, I am sure you have observed that there is a big change in this particular question as compared to the other questions we have seen earlier in partial fraction. Yes, that is true. What you are thinking is, I am sure that there is a function which is given to us and we do not like functions in an integral. Let's just rewrite the question first of all, because we have understood what is supposed to be done. We will write this integral as 1 by x in the numerator and the denominator will be written as log x into 2 plus log x. Now, this is done with a motive, and the motive is we are going to substitute log x as t, because we know that log x and 1 by x are function and derivative pair, and that makes it easy for us to understand that we are going to substitute log x as t. So if I put log x as t, the next step is pretty clear to me. We can write that 1 by x dx is equal to dt, and therefore the integral will become 1 upon, can I say t into t plus 2? Obviously a dt has to follow. Is that okay, my dear students? So we have converted the function into a variable now here. Function is gone from the integral. What we have is a simple variable t. Let's proceed to integrate this. Now my dear students, again we have to observe some points here. Now if I write the denominator as t into t plus 2 as it is, I am not writing the numerator because I am going to do something here. I am going to multiply and divide by 2. Why 2? Because if I see the difference between the two factors in the denominator, the two factors are t and t plus 2. Their difference is 2. I am not considered with the order of difference, only the magnitude of difference. It's 2. And therefore, what I can do is, I can adjust directly. Why? Because 2 is a constant. I multiply 1, 2 inside the integral and 1, 2 I divide outside the integral. So therefore you see that 2 and 1 by 2. Now my dear students, what we are going to do is, we are going to adjust directly. How? Just check. Half I keep it as it is, which is outside the integral. Now instead of writing 2, let me write it as t plus 2 minus t, and the denominator remains as it is. Now my dear students, what is t plus 2 minus t? It is nothing but 2, which was our numerator in the previous case. dt is there, correct? Now if you have understood this, I am sure you understand the next step. The numerator is actually written in terms of the denominator, so we can separate. Is that okay? So half remains outside, and when we separate, we will get integral of t plus 2 upon t into t plus 2 and a dt, minus of integral t upon t plus 2 into t, again a dt. Correct? Now my dear students, in the first integral t plus 2 will get cancelled, in the second integral t will get cancelled. So what we will get is 1 by 2 integral 1 by t dt minus integral 1 by t plus 2 dt. Is that okay? Now my dear students, you may remember this technique as a shortcut also. If I have two factors like 1 upon ab, if I have two terms multiplied 1 upon ab, then I can write 1 upon ab as 1 upon b minus a into brackets 1 upon a minus 1 upon b. 1 upon ab can be written as 1 upon b minus a into 1 upon a minus 1 upon b. My dear students, a and b are constants here, and they can be applied to t plus 2 and t also in this case. Okay, now let's proceed further to integrate. Integral 1 by t will be log mod of t, and that of 1 by t plus 2 is log mod of t plus 2. Obviously a plus c has to follow, correct? Now let us write this in the next step as half log mod of, can I say t upon t plus 2? Thus log of a minus log of b is equal to log of a by b. Plus c is there. Now the question was in terms of x. So let us substitute the value of t, and that is nothing but log of x. So we get half log mod of log x upon log x plus 2 plus c. That's your final answer. Now you need to practice a little bit. So these are the questions which you should try. These are of the same type. That's all we have in this module. Thank you very much.